Hello and welcome to today's video on regression modeling, where we will be diving into the key concepts of estimation and evaluation. If you ever wanted to build efficient predictive models or learn how to assess their performance, you are in the right place. We will break down linear regression, its assumptions, and how to evaluate your models with Python. Let's get started. Introduction to regression modeling. So, what is regression modeling? Regression allows us to predict the value of a dependent variable based on one or more independent variable. It is a powerful tool to understand relationships within data, forecast outcome, and reveal valuable insights into complex phenomena. For predicting sales and customer behaviors in marketing to access medical risk factors in healthcare, regression is widely used across various industries. Next, we have the assumptions of linear regression. Before we jump into modeling, let's revive the assumption that underpin linear regression. First, there is linearity. This means that the relationship between the independent and dependent variable should be linear. Think of it is as a straight line through the data points. Next is independent. The observation should be independent to each other, meaning that the value of one data point shouldn't influence other. Normality is another assumption. The residuals or the difference between the actual and the predicted values should follow a normal distribution. Finally, homodysticity means that the variance of residuals is constant across all levels of the predicted values. This ensures that the model's accuracy is consistent. Next in we have evaluation performance model. Now let's talk about how to evaluate the performance of your regression model. First we have R squared. The metrics tell us the proportion of the variance independent variable that's explained by the model. A higher R squared value means a better fit. Next, mean square error (MSE) measures the average squared difference between predicted and actual values. The lower MSE, the better your model accuracy. RMSE is the square root of MSE and gives you an interpretable measures of error in same unit as dependent variable. Finally, adjust R squared by considering the number of predictors in the model. This helps to prevent underfitting when you add too many variables. Next in we have demonstrating estimate in Python. Now let's see how to implement linear regression and evaluate our model using Python. Step 1. Import libraries. Start by importing necessary libraries. We will use pandas for data manipulation and linear regression for stick-learn. Step 2. Load and fit data. Load your data into a Panda data frame and create a linear regression model. Refer the below code. Our next topic is interpreting regression coefficients. Once you have fitted your model, it's time to interpret the results. Start with the regression coefficient value. The coefficient tells us the change in the dependent variable for one unit increase in the independent variable while keeping all other variables constant. Next, p-value indicates whether the coefficients are satisfyingly significant. A low p-value means the variable is a significant predictor of a dependent variable. Next in we have evaluation model fit diagnosis. To ensure the model assumptions hold, we need to evaluate its fit and run diagnosis. Start with the reducible plots. This plot shows the difference between actual and predicted values. They help access assumptions like linear and homodysticity. Next, apply statistic data Test like the Scorpio will test to check if the residuals follow a normal distribution, and use Cook's distance to identify influential data points that could disproportionately affect the model. Next in we have stepwise regression. Now look at the stepwise regression, which automates the process of selecting the best predictor variable for the model. Forward selection. With forward selection, we start with an empty model and add variables one by one. Keeping one those the significant improves the model. Back elimination starts with overwhelm all variables and removes them one by one, keeping only the significant predictors. Stepwise selection combines both forward and backward step, adding and removing variables based on statistical criteria. Next in we have implementation stepwise regression in Python. Here's how to implement stepwise regression in the Python using stat models. You can refer the code which is written on screen for the linear regression. Our next subtopic is evaluating stepwise regression models. Once we have created our stepwise regression model, we evaluate it just before, just before model fit. Use metrics like adjusted R squared and MSC to access the model's fit. Variable significance. Look at the p-values to see which variable are satisfyingly significant. Model diagnosis. Finally, apply model diagnosis to check if the model assumptions hold. In summary, regression modeling helps us to understand relationship between variables, make predictions, and undergo variable insights. By evaluating the model's performance using metrics like R square and MSC, and diagnoses its assumptions with residual plots and normality tests, we can ensure our models are robust and reliable. Thank you for watching. For any questions, please comment down and drop them, and I will be happy to help you. See you in the next video. Thank you.